All right, we're going to be looking at a couple different application problems and really looking at graphing direct variations. So we have a group of people are tubing down a river at an average speed of 2 miles per hour. First, we're going to write a direct variation equation that gives the number of miles y that the people will float in x hours, and then we're going to graph it. Okay, perfect. So I want to just go ahead and say, okay, this is the average speed, right? We know we're doing a direct variation, right? So it's going to be y equals kx. So then we just need to determine what is k. Well, k is the average speed. So k is equal to 2. So our equation is just y equals 2x. That is our direct variation equation. All right, boom, that's it. Now let's go ahead and graph. So to graph, what we want to do is we want to label these x and y axes, and it really tells you what x is. What does it say? Float in x hours. So that means this x-axis is the number of hours, or time in hours. You know, that's what they would say, time in hours. And then this is the number of miles. So we could say distance in miles. Okay, and then we're just going to go ahead and graph this. So what do we know about this direct variation? Well, we know that the y-intercept is 0, right? So there is 0, right? Because basically the direct variation is just the same thing. Y equals kx is the same thing as slope-intercept form, which is y equals mx plus b. And remember, whenever we graphed anything with slope-intercept form, we graph the y-intercept first and then the slope. So for this direct variation, the y-intercept would be 0. So, and then the slope is just the same thing as the k, which is 2. All right, and we make that a fraction, which is 2 over 1. So we just graph the y-intercept first and is 0, and we know that all direct variations equations always go through 0, right? And then from there we do the slope, so up 2 over 1, because the slope is just y in x, right? It's the change in y over the change in x, or it's the rise over the run. All of these things mean the same thing. So from this y-intercept is 0, we go up 2 over 1, and then up 2 over 1, and then up 2 over 1. Right there, yeah, up 2 over 1, up 2 over 1, up 2 over 1. And there we have it. There is our wonderful equation, and I cannot find my little protractor ruler. Where did it go? Oh, here it is. I found you. Okay, so I'm gonna get my straight edge here. Go ahead and graph that line. It's an arrow, it keeps going. Since this application is talking about time and distance, we're only gonna be looking in that first quadrant, right? And so we don't need any negative numbers for this application. But if you were just graphing a direct variation in a regular coordinate plane, then you would just, you know, have that line extend in both directions forever and ever. But just because this is an application, it's kind of restricted, so it's just from the y-intercept and all the way up. Okay, perfect. All right, let's look at this next example. Check it out, example 4. All right, and I want you to go ahead and try this one on your own. So here's my friend. Where is my friend? Oh, here's the pause dragon. Remind you to pause your device. Go ahead and work this problem out. When you get done with it, press play and we'll go over it together. All right, see you in a bit. Okay, let's see how you did. So this says the perimeter y of a square varies directly with its side length. Okay, so the first thing we have to do is write a direct variation equation for this relationship and then graph it. Did you see something? I did. There's keywords. Varies directly. Okay, varies directly. So we have the y information, which is dealing with the perimeter of the square, and then the x, which is dealing with the with the side length. So we want to go ahead and write a direct variation first. So a, right, is going to be y equals kx. So let's think about this. What is that constant of variation? Well, what are we talking about? We're talking about the perimeter of a square. So let's think about that for a second. So if we have a perimeter of the square, perimeter is the distance around a square, right? So if I start here, this plus this plus this plus this, that is what the perimeter is. It's the distance around a square. And what do you know about a square? All the side lengths are the same, right? So what is this saying? It's with side length x. So that means this side is x, this side is x, this side is x, and this side is x. So if I was going to find the perimeter, I would go x plus x plus x plus x, right? Which is actually x plus x plus x plus x plus x, right? You just add up all four sides, which is the same thing as the perimeter being 4x. So look at that. If we change out perimeter, which perimeter is actually equal to y, we have our direct variation. Look at the perimeter of a square is actually a direct variation. Isn't that crazy? Where the constant of variation is actually equal to is equal to 4. The constant of variation is equal to 4, which is the slope. Okay, so now we're gonna go ahead and graph this. Remember, to graph this line, we're gonna think about slope-intercept form, right? So what is our intercept? Our y-intercept is 0. And then our slope is the same thing as a constant of variation, which is 4, which we're going to write as just 4 over 1. We're going to write that as a fraction. So whenever we, let's label this first. The x is, that's referring to the side length. And then the y is the perimeter. Okay, and this is just talking about the perimeter of a square. Okay, perfect. Okay, let's go ahead and graph this now. So y-intercept is 0, which makes sense because every direct variation, the y-intercept is always going to be 0. It always goes through the origin, which is 0, 0. And then from here, we're going to graph the slope, which is up 4, 1, 2, 3, 4 over 1. And then we're going to do it again, up 4, 1, 2, 3, 4 over 1. And there we have our direct variation. We just connect those lines, and we have it. All right, that is how you graph direct variations. Graph the y-intercept, always 0, and then from that y-intercept, then you graph the slope. So if you got that correct, awesome job. That is it for this lesson. You did an amazing job. I will see you for the next lesson soon.